are here to learn more about the concept of circles. Before that, let's recall what a circle is. Circle is defined as the set of all points in a plane which are at a fixed distance from a fixed point in the plane. The fixed distance is called radius and the fixed point is called center. Circles are used extensively in our day-to-day life. So, getting to know more about circles is important. Specifically, in this section, we will identify what a tangent line is and explore the properties of tangent lines and its theorems. We will also identify secant lines as well as we will discuss about how they are different from the tangent lines. Circle and a line drawn on a plane. For a circle and a line PQ drawn on a plane, there can be three possibilities. The first possibility, when the line and the circle have no common point. In this case, line PQ is a non-intersecting line since it does not touch the circle. Second possibility, when the line and circle have two common points. Here, line PQ touches the circle at 2 points, that is A and B. In this case, the line PQ is called a secant of the circle. So, a line intersecting the circle in 2 points is called a secant. Now, the third possibility, when the line and the circle have one common point. In this case, there is only one point, that is A, which is common to both the line PQ and the circle, and the line PQ is called a tangent to the circle. Now, let's discuss tangents in detail. Tangent to a circle is a line that intersects the circle at only one point. The common point of the tangent and the circle is called the point of contact. Here, point G is the point of contact. The tangent is said to touch the circle at the common point. Tangent is a special case of a secant. Let's see how can you say that tangent is a special case of secant. For that, perform an activity. Draw a circle and some secant lines, each parallel to the other. You will find that after a few secant lines, the length of the chord cut by the lines gradually decrease. That is, the 2 points of intersection of the line and the circle, they are coming closer and closer. Finally, they coincide. That is, their point of intersection now becomes at one point, which is shown in green lines, which are the tangents to the circle and they are parallel to the secant lines. Thus, we can say the tangent to a circle is a special case of the secant when the two end points of its corresponding chord coincide. Also, from this activity, we can understand that there cannot be more than two tangents parallel to a given secant. Now, a question arises, how many tangents are possible at a point? As you can see in the figure, black dotted lines touch the circle at more than one point, while the red line touches the circle exactly at one point, which is the tangent to the circle. Thus, we can infer that at any point on a circle, there can be one and only one tangent. Next, we will discuss another term, that is normal to the circle. The line containing the radius through the point of contact is called the normal to the circle at that point. In the figure, G is the point of contact and OG makes the normal. Right? Now, another question which arises in my mind, how many tangents can a circle have? As we all know that there are an infinite number of points on a circle and at every point there can be only one tangent. Hence, there are infinite number of tangents in a circle. Next, we will discuss an important property of a tangent. We have already seen that there can be only one tangent at any point on a circle. And there is some peculiarity for this tangent, which is a very important property, that is, the tangent at any point of a circle is perpendicular to the radius through the point of contact. We shall now prove this important property of the tangent, which is stated in the form of a theorem. The theorem statement is, the tangent at any point of a circle is perpendicular to the radius through the point of contact. Given a circle with center O with tangent xy at the point of contact P. To prove OP is perpendicular to xy. Proof. Let Q be a point on xy. Join OQ. Suppose it touches a circle at point R. Hence, we can say OQ is greater than OR since OQ is equal to OR plus RQ. OQ is greater than OP as OP is equal to OR, which is the radius. Same will be the case with all other points on the circle. Hence, OP is the smallest line that connects a XY. And the smallest line is perpendicular to XY. Therefore, we can say OP is perpendicular to XY. Hence, proved. Now, let's see some real life examples of tangents to a circle. First one, when a circle moves along a road, then the road becomes a tangent at each point when the wheels roll on it. Second, another example you can see a person performing discus throw. Here, the discus goes in a direction tangential to the circular motion. Let's have a recap of what we have learned. We have seen the difference between a secant and a tangent. A line intersecting the circle in 2 points is called a secant, while tangent to a circle is a line that intersects the circle at only one point. Then we were discussing all about tangent, its basic concept and its various terms related to it, that is point of contact, what is normal to the circle. The common point of the tangent and the circle is called the point of contact, and the line containing the radius through the point of contact is called the normal to the circle. Then we discuss the number of tangents. At a point, there can be only one and only one tangent, and for a circle, infinite points are there, so infinite number of tangents are possible. Also, we discuss a very important property of tangent and its proof. The tangent at any point of a circle is perpendicular to the radius through the point of contact.